let's work on some problem solving questions with quadratics. So this question says, does a quadratic function with vertex 3, -4 and y-intercept of -2 also pass through this point here? So in order to figure out this solution, we need to have an equation, because if we have an equation for this parabola that is describing, we can figure out if this point is part of the equation. So we have multiple equations that we can use for a parabola. We have vertex form, factor form, standard form, and it makes sense that we would use vertex form here because we're given the vertex. So vertex form is going to look like this. So let's come up with the equation for this by plugging in the vertex 3, 4. So we almost have an equation. We need to find the value of a in order to have this as a completed equation. So we have to use our other piece of information, which is our y-intercept. So we know that the point 0, -2 is on this parabola. So that's what I'm going to plug in for f at n, f at neg n. That's what I'm going to plug in for x and f at x, or y. So instead of f at x, I'm going to plug in -2. And instead of x, we are going to plug in 0. And let's just simplify this and come up with our a value. So we've got -3 squared minus 4. And then we have a 9 minus 4. And then we're making sure that we're not doing 9 minus 4, because this is 9a. These are not like terms here. So we're going to bring this -4 into the other side. It becomes +4. We have 9a on this side. We've got 2 is equal to 9a, and then we have 2 over 9 is equal to a. So that's our a value. So now we have our equation of our function. So we know it's going to be f at x is equal to, our a value is 2 over 9, and then we've got our vertex, which is -3 and -4. Now that that's done, we can answer the question. Does this function pass through this point here? So what we're really asking is, does this point exist on this equation? So we have this point here. Does it exist in the equation f at x? So the easiest way to figure that out is just plug in x is equal to -1.5, and let's solve for y, and we're going to see if y is equal to 4. If y is equal to 4, then we know that this is a point on the parabola. So let's plug in f at -1.5 and see what happens. So we've got 2 over 9, -1.5 minus 3 squared minus 4. And if we plug that all into our calculator, we get that f at -1.5 is equal to 0.5. So that means that the point -1.5, 0.5 is on the parabola. So that means that it's not possible to have this one on the parabola as well. Let's take a look at another question. It says a rectangular lot is bordered on one side by a stream and on the other 3 sides by 600 meters of fencing. So let's just draw that picture really quickly. So we have a rectangular lot that's bordered by a stream on one side, and then 3 other sides with 600 meters of fencing. So what we know is that the perimeter is equal to 600 meters. And the question is, what is the maximum dimensions? What are the dimensions of the lot to make a maximum area? So we know we have 600 meters of fencing to work with. So let's give these names. So I'm going to call these guys the widths, and I'm going to call this one the length. So can we make an equation to include this perimeter of 600? What do we know about this situation in terms of coming up with an equation? Well, we know that the width plus the length plus the width must equal 600 meters. So how can we write that? We can write that 600 is equal to 2 widths plus a length. Does this make sense? We're not doing 2 lengths because there's only 1 length in this picture, in this situation. So let's go back up to the question and figure out what haven't we used. It says find the dimensions of a lot with maximum area possible. So we're looking to find the maximum area. So we're looking to find, we know the area of this guy here is going to be length times width. So I'm going to write that down as my second equation. So we have this first equation here, We have this first equation here, we have this perimeter equation. We've got the second equation here for area, and we know we're going to maximize this, which means we're looking for a vertex. So this has to be a parabola, and we're going to find the vertex of it. But we have to include this information into this equation that we're trying to find the vertex of. And so how do we get this equation into this equation here? We can isolate for a variable and then substitute it in. So the question is, what variable here is easiest to isolate for? And it clearly is L. L is already almost by itself. So if I move that 2W over, we have now an equation that's isolated for L, and we can plug it into this equation right here. And then all of the information that we need is all in one equation. So instead of L, we're going to put 600 minus 2W, and then we have W. What to do now? Well, we're looking for the maximum area, right? Well, we have a parabola, or do we have a parabola? We don't know. Do you notice that if we expand this, we're going to get W squared? So because of that, let's expand this in, and let's just make sure we do have a parabola. So I'm going to write this in standard form. So I'm going to move the W squared first. And now we have a parabola that we're going to find the vertex of. So you could do two things. You could complete the square here, or you could factor, find the zeros, then find the axis of symmetry and plug it in. Whichever way you want to do it is perfectly fine. I'm going to complete the square just so that we change it up a little bit. So I'm going to factor out a -2 out of the first two terms, just like that. And then what number are we going to add and subtract here? So we've got -300. We're going to divide it by 2 and square it. And we're going to get 22,500. So I'm going to add 22,500 and subtract 22,500. Doing this now, it might have been faster to factor and find the axis of symmetry, but we're committed to completing the square here, so no problem. What's the next step here? Let's kick this guy out of the bracket. Let's move this up a little bit. We're going to kick this guy out of the bracket here, and then we have -2W squared minus 300W plus 22,500. Before we kick this guy out, we know it has to get multiplied by -2. So we're going to multiply this guy by -2, and we get plus 45,000. Let's finish this off by factoring. So the fastest way to factor this, because we know it's a perfect square, is to take this -300 and divide it by 2. And so we're going to get W minus 150 all squared. That's what that thing's going to be factored, plus 45,000. So what is the vertex that we found? A reminder that you could have done this by finding the zeros, finding the axis of symmetry. Absolutely do it that way. But we found the vertex by completing the square, and we found that the vertex was 150, 45,000. So it doesn't matter which way you did it, we're all coming to the same conclusion. So what does that vertex mean? Well, we know normally points are written x, y. What variables do we have now? Well, take a look at our equation here. We don't have x, we have w. So this is w. And instead of y, we have a. So this is our a. So this is our width that will produce this maximum area because it's the vertex. So the max area is going to be 45,000 units. So this is the max area. And this is the width that will create this, 150 meters. So let's go back to our picture here. Now we know that each of these widths have to be 150 meters. What about the length? Well, is there anything on this page that can help us find the length? Look at this lovely equation here. We have an equation for the length, so let's use that guy here. So we're going to write down that we know that the length, so I'm just going to box that we know what the width is, and we know that the length is equal to 600 minus 2W, and the length is equal to 600 minus 2. We know the width is 150. And we know that the length is going to be 300. So that is our conclusion. Therefore, you can write that down. I ran out of space, but in conclusion, just write a concluding sentence. In conclusion, the dimensions that will make the maximum area is a width of 150 and a length of 300. Let's try another one. It says that the base of a triangle is 2 centimeters more than the height. The area of the triangle is 5 centimeters squared. Find the base to the nearest tenth. So we have no idea how to solve this. So let's just go with what we're given. And let's come up with some equations and see how we can break down this solution. So let's start with the first part here. The base of a triangle is 2 centimeters more than the height. Since this is talking about a triangle, I'm just going to do a quick sketch. We know this is what triangles looks like. We have a base here. We have a height here. So we can do some let statements saying that let H be this and let B be this. We could have also done that for the previous question, but it's reasonable if you have a sketch and you label your letters there, just like we did on the previous page. That's what we did. Then it's reasonable for me to understand, or any reader really, to understand what you have define W and L as. So if you want to be super safe, you can define B as the base, H as the height. But if you've got a picture here, like defining it implicitly, then this is fine. So we know B will call for the base and H will call the height. So as the base of a triangle is 2 more than the height. The base is 2 more than the height. Let's make an equation for that. Base is 2 more than the height. Literally translated it word for word. Base is 2 more than the height. Done. So here's our first equation. We're given another piece of information, which is that the area is 5. Notice how in the previous example, we weren't given the area. We just told the area was a maximum. So we didn't have a letter in for A. See here? We just had a clue that we were looking for the vertex. So we didn't need A because we're looking for the vertex. Here, this question must not be looking for the vertex because it gave us what the A is. We're looking for a particular point. So the area of the triangle is 5. Let's come up with an equation for that. So we know that the area of a triangle is base times height divided by 2. And we know that it's 5. So there are 2 equations. Then it says, what is the base to the nearest tenth? So we're just looking for a particular point here. We're not looking for the vertex. It doesn't say anything about that this is the maximum area or the minimum area. So to solve this, we just have to solve both of these equations. And to solve both of these equations, we need to put them into each other. So the question is, which equation is it easier to isolate for? And I'm always going to look at the linear equation. See how these 2 variables are multiplying? I don't want to isolate for any of them, because if I isolate for B, I'm going to have it divided by H here. I don't want that. This nice linear equation is already, one of the variables is already isolated for. And if it wasn't, it'd be so easy to get them by themselves. So I'm going to input the linear equation into the nonlinear equation. So I'm going to input this guy into here. So we have 5 is equal to, instead of base, we have 2 plus H, and then H divided by 2. Let's keep expanding this guy and simplifying. So we've got 2H plus H squared divided by 2. I'm going to get rid of the divided by 2 just by multiplying by 2 on both sides. So I've got 10 is equal to 2H plus H squared. And let's keep simplifying this guy. 2H, and then we have got minus 10. So how do we solve this equation? We know there's no point. Why are we finding the vertex here? Don't find the vertex. It doesn't ask us to. We have an equation where we have this number on the other side. See how in the previous question, students get this confused so often. We don't know what the A value is because we're solving for the vertex. So we don't know what this A value is. We don't need to know what that A value is. Here, we just have an equation that we're solving. Okay, so we're looking for a particular point. So how do we solve for this? We can try factoring. Are there 2 numbers that multiply to -10 and add to 2? 5 and 2 will never make 2. 10 and 1 will never make 2. So we have to use the quadratic formula here. So I've gone and inputted the values into the quadratic formula. I am going to simplify what's under the square root first. So I'm going to simplify this guy first. So now we've got that simplified. We're going to come up with now what our two x values will be. So we're going to throw that into the calculator. So here are the two x values that we found. So what did we even solve for? So let's go back to our original equation. Our original equation actually has h instead of x. So I'm going to go through here and change all of our x's to h. So this is really h equals h equals h equals. So these are the two heights that we came up with, 2.32 and negative 4.32. Do these both make sense? We know that h is defined as the height of a parabola. So it cannot be this one here. This is our only h. So our h value therefore is, I should have given myself more space. So therefore the height of this triangle is 2.32 centimeters approximately. How do we find the base? Just go back to the question. Here's an equation for the base. We can solve for the base by just plugging in our h, which is 2.32. So our base is going to be 4.32 centimeters. And that's our conclusion. So therefore the height must be 2.32 centimeters and the base must be 4.32 centimeters. Let's try one more problem. It says, what are two numbers that produce a minimum product and whose difference is 9? Here we see this word that implies that we're looking for the vertex again, minimum. Vertex we know is either going to be the smallest, the smallest y value or the biggest y value on a parabola. So in this case, this problem must be upwards facing and has a minimum. So we know it's not going to be an example that we're given an answer for one of our equations. It must be an example where we don't know what our y value is and we are instead just solving for the vertex. So let's take a look. Let's just make the equations that we can from this and go from there. It says, what are two numbers that produce a minimum product? So first of all, we need to label the two numbers. So we have a is equal to one of the numbers, so the first number, and b is equal to the second number. So now we've got variables defined. We've got a and b. So let's come up with some equations. So we're looking for a minimum product. So the product we know is created by multiplying the two numbers. So here we go. And it says, the other thing that we're given is that their difference is 9. Their difference is 9. So 9 must be the two numbers subtracted from each other. So that's our first equation, and here's our second equation. So just as a side note, this only works if the a value is bigger than the b value. So I'm going to make a little note here. First number, I'm going to say that this is the bigger one and that this is the smaller one. So that's how their difference can be 9. So now this looks like the example that we did before about the garden. We have to somehow get this guy into here. Well, it's really easy because all we have to do is isolate for a variable, any one. Maybe I'll isolate for a because it's already positive. And then I'm going to plug it into the thing to the other equation. So here I go. I isolated for a. I brought b over. So we're going to input this guy into here. So we have our product is equal to, instead of a, I'm going to replace it with 9 plus b. And then we have b here. So if you ever get in the middle of a problem and say, what am I even finding? Go back to the question. We're looking for a minimum. What does that mean? We're looking for a vertex. So don't freak out that we don't know what the product is. It's not like the question we did above because we're not solving this equation. We're looking for the vertex. So we can't find the vertex unless it's at least in standard form. So let's expand this here. So we've got b squared plus 9b. So now we got to find the vertex. In the previous, or 2 questions ago, we did completing the square. I'm going to do this by factoring, okay? I'm factoring. I'm going to find the x-intercept. So here I go with the factoring. So I factored this guy, I'm going to find the vertex. We know the steps of finding the vertex. We are going to find the x-intercept first. So we're going to find the x-intercept, which means we need to set our y value to 0, or in this case, p equals 0. So here we go. And now we can pull out our x-intercepts. Our first one's going to be 0. Our second one's going to be -9. What's our next step if we're going to find the vertex this way? We're going to find the axis of symmetry. Axis of symmetry. So here we go. I'm going to find the axis of symmetry. Instead of x, I'm going to use b. So I'm going to add them together and divide by 2. So our axis of symmetry is -4.5. So this is the x value of the vertex. The x value of the vertex. So now we can find the y value of the vertex. The y value of the vertex is going to give us the p, the product. But is this question asking us for the minimum product? No, it's asking us for the two numbers. So we could go and plug this in and find the y value of the vertex. That will give us the minimum product, but it's not asking us for that. So let's just skip that step. We know what's going to create a minimum product is a b value of -4.5. Notice that it didn't say that the numbers had to be positive. So this is fine. So now we just got to find the other number. So let's take a look at our whole page. What can we use to find the other number? This guy right here. We can use our first equation, which is that 9 plus b has to equal a. So let's solve for a here. I'm going to put 9 plus, and I've got -4.5. And our a value is 4.5. So here are our two values, 4.5 and -4.5. Does this make sense? They make a minimum product. We can check what that product is by just multiplying them. The a is the first number, it should be bigger. It is. B is the second number, it should be smaller. It is. So therefore, we can do a quick therefore statement. Therefore, the two numbers are 4.5 and -4.5. Oh, and also notice their difference is 9.